I want to start recording this. Okay, so we did 2 the other day and 3, because that's where we finished off the other day, yes? With this funky looking one. Now we have this even funkier looking one, yes? I will tell you this right out. On the ACT, I would want a lot of these. I want all of these. Is there a variable anywhere in there? It's just all numbers, yes? So that means I can grab the calculator, the yellow, I'd use the yellow calculator for this. Hit the fraction key, 1 in the top, over 3 plus. Fraction key, 1 over. Then in the bottom, 1 plus. Fraction key, 1 over 4. Enter. Because if it's all numbers, plug it in. Because if we tried to do this by hand, we'd 1 over 3 plus 1 over, well, 1 plus 1/4 would give me 5/4. Well, I can't leave it as 5/4. I have to do our resolve this here, which ends up being 4/5. Well, I've got to convert this so the denominators are both 5, which would be 15 and 4, which is 1 over 19/5, which gives me G. Or heck, type it all in. There's a lot of them on the test that you can type them all the way in and get it done. Now, Ann and Emily are the only 2 that have finished Algebra 2, yes? All the way through? Because I think the rest of y'all are either, Emory, did you take Algebra 2 last year? No? Okay. I couldn't remember. But the rest of y'all are in Algebra 2, so I think I heard somewhere that there was I on the test. If y'all haven't dealt with that yet, y'all don't have a clue what it's even talking about. But on the graphing calculator for decimal or 0 is I. It will do I. And luckily for y'all in Algebra 2, that's coming up in a few weeks, because that's in Chapter 3. We just haven't gotten to it yet. Second decimal. So it's catalog? Nope. So second decimal. Yeah. Yeah. So I was just straight down there at the bottom of on the actual calculator. Mm-hmm. Now this here's the next one we'll look at. What fraction of 3 1/2 is 1 1/6? So what fraction of 3 1/2 is 1 1/6? It is. Yeah, because I think we're doing 1 1/6 over 3 1/2. And we could do this division here, or we can actually convert it to 7/6 over, because 2 times 3 is, plus 1 is 7. And we could type it in there, or 7/6 divided by 7/2, which would be 7/6 times 2/7. 2/6 is 1/3. Or really, what fraction of is what operation? Multiplication. So what fraction of 3 1/2 is 1 1/6? We're trying to solve for x, so we would divide both sides by 3 1/2. We kind of good with this here? Y'all can do that, yes? Yep. Trying to remember my colors. Okay. That one there is homework. That one there is points. So I'll write them down here in a little bit. Ah, there's the next one. 11. 11. Massive word problem. When Elton was cleaning his garage, he found 2 bottles of motor oil. According to the label, the capacity of the large bottle was 3 times the capacity of the smaller bottle. He estimated that both the smaller and large bottles were about 3/4 full of motor oil. He poured all the motor oil from the smaller bottle into the larger bottle. Then, about how full was the larger bottle? Does A even make sense? No, because how full is it right now? 3/4. So is it going to go down? No. Okay. 9/16. Because what is 9/16? Or 9 divided by 16 as a decimal? Because, yeah, it'd be about 0. Go on and plug it in. Let's see. Because it's, I think, should be 6 or 7.
0.5625.
Well, wait a minute. 3/4 is 7/5. So does 9/16 make any sense? No. 7/8. Okay. 875. Okay, that could be some sense overflowing or completely full. Well, have we even tried to tackle the problem yet? No, we know about filling canisters. It should go up, yes? That's 2 gone. At this point, even if I just had to guess, you have a 33% chance of guessing right. Over 20% of just trying it right out the gate. So that did help. Now, let's dig a little deeper into the problem. Now, we said the larger bottle was the capacity of the smaller. So the larger is 3 times the capacity of the smaller. Yes? So for every part of the smaller, it's going to take 3 of them to be the same as the bigger. Yes? So so if one of them's 3/4, so the larger is 3/4, and the smaller is 3, we're going to try to get them into the same units. So for the larger, what they told, or kind of we're working through, was saying 3/4 times 3x. And for the smaller, and essentially what we're doing here is just getting it in terms of 1 unit. Now, when I multiply the larger by 3, really it's converting it into the smaller, because for every 3 of the smaller, I have 1 of the bigger. Or for every 1 of the bigger, I have 3 of the smaller. So in terms of overall size, 3 times 3 is... So whatever the amount is, they never told us. In terms of the smaller, it's 9/4. Would be the same for the smaller. For the smaller, well, it's just going to be 3x over 4. Yes? Now, if I add these two together, well, the denominators are already the same, yes? What's 9 plus 3? 12 divided by 4 is? And this is in terms of the smaller, yes? Well, what's that the same as? So what is it? It's completely full. Because we could have gone the other direction and really divided the smaller amount by 3. I saw that. So if we said 3/4 divided by 3, plugged it in, we would get 1/4. 1/4 plus 3/4 is 1, so it's completely full. And that's it for that there. Now this is the last one we're going to do together, is this one here. Now, how many of y'all seeing this here would have skipped this problem outright? Probably. How many of y'all are in ag or have dealt with welding or cutting? Yes? Once we look at this, it's going to actually make this a little bit easier. Pablo works in a factory and has to cut a rectangular metal rod into small cubes. So we're cutting it apart. The rod he uses, or the rod that he needs to cut, is 1/4 by 1/4 by 8 feet. They provided a picture. And he needs to cut it, and he will cut it that it will be cubes of 1 1/4 inches on each side. So that means it's 1 1/4 inch by 1 1/4 inch. Well, that really doesn't matter. The length is going to be 1 1/4 inch. He must allow an extra 1/2 inch for each cut between his saw blade, because the saw blade's a 1/2 inch, because we always lose material whenever we cut. Assuming that the metal rod has no flaws, what is the maximum number of cubes he can make from his 8-foot metal piece? Okay. So what do I know for sure? Because as I'm cutting, I'm losing a 1/2 inch each time, yes? Will I always have a 1/2 inch that I'm losing off every single one? There should be one that I don't, right? Because what's going to happen when I get to the very end, it'll cut it in to 2, and the last one shouldn't have it, right? So, I mean, we could go through and think about it that way, because if you've ever cut and just thought about cutting it up, that works just fine. Use that logic and cut it apart. Because, I mean, heck, we could just say, okay, it's 1 1/4, but that's 8 what? Feet. What are we dealing with? 12 inches in a foot, so this should be 60. So we could do exactly, I think, Amory, you were saying it was 1 3/4, yes, because we add those together. And what is 60 divided by 1 3/4? 54.
I got 34 and 2/7.
34 and 2/7. Because we could also say that this is 7/4. That might work a little better. But it'll be a little bit, it should be actually really close to what the correct answer is.
Okay. Let me change. 7/4, 2/7.
Yep, 7/4. Because if you do just multiplication, it'd be a little weird.
I got the same thing.
Okay. Yeah, because that should be 1 3/4. So that doesn't work out quite well. But what we did know is that one of them will be exactly 1 1/4, or minus 1.25. Because the last one that we use will be that exact dimension. We don't have the extra to take off. So that'll tell me that I have 58.75. Mm-hmm. Now what we can do next is take this here, because the rest of them will have that extra 1/2 inch, and divide it now by 1.75. And I think we'll get 54 point something.
Plus 1.75.
Uh-huh. It should be a lot bigger. 0.75 divided by 1. Really weird. Because it should be given something a little bit.
8 times 12.6.
Yes.
There we go. I thought it was 96 earlier.
Yes.
But,
That should be 96.
there we go. By golly, we got her figured out.
We got her figured out eventually. Yep. Let's try this again. 96 divided by 1.75.
54.857.
Well, that is pretty close to G, yes? Now that is the correct answer. Now if we did it the way that we're technically supposed to mathematically, would be to subtract the last piece, the 1 1/4, which would give us 94.75. Divide it by the 1.75, which would give us 54 point, I think like 4.3, something like that. But 1.4. But remember, we took one off to begin with, so we would add it back and get 55.14. But again, the extra that we added in with the 0.75 was an extra half. But we got close enough for our own sake. So is it possible to have done this without knowing the mathematical way to look at it? Because, I mean, if you've cut rods or cut things up into shapes, we could have logically just approached it and got to the same spot, yes? So some of the word problems, if we just think about it logically and go at it, it's the same thing. Questions on this here? And that's it, because now I will, for those of you, for all of us, especially when we're ordering fractions, if you have trouble ordering them, turn them all into decimals and order the decimals. Okay. So in class, we did 2, 3 through 5. 11, 12. Homework. 1. None of that. 7. 10. 14, 15. Make sure I didn't miss one. Ah, I did. You can add it back in there. It should be 6, 7, 10. 7, 10, 14, 15. And then the last 3 are going to be points. 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 13. Now, for the overall points, I am giving you credit for the ones we do in class as long as you do answer them and have them answered on the paper. I am giving you points for that. Now, also going along with the points, I talked with Miss Ellis and we kind of agreed on this, is that the points after the 2 weeks, because I told y'all after 2 weeks I'm just going to throw zeros in until you guys get it turned in, because I will give you that time to make it up. But also after that 2-week spot, I'm nixing the points for it, okay? Because if you get it turned in within the 2 weeks, you'll get the points and the grade. After the 2 weeks, you will get the grade, but not the points, okay? But that is it for today.